Last up for this worksheet, we're going to talk about the distance formula, which is kind of an application of the Pythagorean theorem, which we already know is an application involving the square root property. So at some point in your pre-calculus career, you'll see the distance formula for sure, okay? Now the distance, we're going to call it D, between the points x1, y1 and x2, y2 in the rectangular coordinate system is D equals the square root. You take the difference in your x's and square it, add that to the difference in your y's, and then square that, okay? So when we think about this, and we'll go to a piece of like graph paper in just a moment, think about this. We're going to have two random points on the XY Cartesian plane, okay? We want to know the distance between them. Literally, what is the length between these 2 points? Well, in order to do that, we basically create a right triangle, and then we apply the Pythagorean theorem to it. So let's go ahead and scoot over to kind of a generic piece of graph paper. Okay, so let's say that we have the Cartesian plane in here. We're going to put it right here. Pretend it's perfect. Okay. And then let's say we have a point here. We're going to call it x1, y1. And then let's say we have this point right here, which we're going to call x2, y2. Well, we want to know this distance or this length. Well, if you look at it, we have some distance across the x-axis, and then we have some distance along the y-axis. This creates a right triangle, okay? So we're going to say that this side is A, this side is B, and as always, the hypotenuse is C, okay? And so what's happening here is A is the difference in x's, or distance along x-axis from point x1, y1 to point x2, y2, okay? And then what B is B is the difference in the y's, okay? So it's that vertical distance, okay? Which is the distance along the y-axis from point x1, y1 to point x2, y2. So let's see what that is. So if we're starting here, we would go over 1, 2, 3, 4, 5, 6, 7. And then from this point right here to this point right here would be 1, 2, 3, 4, 5. So there's a distance of 7, there's a distance of 5. We can throw that into the Pythagorean theorem and essentially get the distance of C. We can find length C. So we have C squared equals A squared plus B squared. Well, if I wanted to go ahead and take the square root of both sides, I would get the square root of C squared equals the square root of A squared plus B squared. Well, the square root of C squared is just C. And remember, we said that A is the difference in the X's and B is the difference in the Y's. So let me scroll down just a smidge. So that tells me that C is really x2 minus x1 squared plus y2 minus y1 squared. So that's kind of where that formula comes from. This really is just a secret application of the Pythagorean theorem, which is just an application of the square root property. So remember, we decided that A was 7 and that B was 5. We could throw those numbers in here and we could figure out what the length of C was. So we could say, okay, the difference in the X's ended up being 7. The difference in Y's ended up being 5. So we would get 49 plus 25. Let's go to the calculator really fast. Where am I at? Here. Nope, here. So then we could say, okay, we've got the square root of 49 plus 25, and we get 8.6, we'll say approximately. So if we were to go back here to our graph paper, we would say that this is approximately, let's go ahead and make it approximate because we did have to round. And it was 8.6. And that would be the length of side C. Okay? And that makes sense because the hypotenuse is always the longest side. It's longer than A or B. So that's kind of secretly what we're doing. We're just given the formula and told to like trust the process, but this is the process. This is what's happening behind the scenes. So let's go ahead and practice. So we'll go back to the original worksheet. Okay, so example 3 says find the distance between each pair of points. Okay, so for part A, I'm going to try to keep the formula on the screen so we can see it. So part A, we have -3, 6, and then 3, -2. So let's say that this is x1, y1, x2, y2. And we're going to say the distance between those 2 points, that kind of becomes the hypotenuse. It equals the square root. Well, I'm going to take x2 and subtract y2. So x2 is 3. And then I want to subtract y2, which is -3. So watch your signs. We want to square that. Plus y2 is -2 minus y1 is 6. And we want to square that. Well, 3 minus -3 is really just 6. And then we want to take 6 and square it. So we get 6 squared, which is going to end up being 36. And then -2 minus 6 is -8. We want to take -8 and square that. So let's see, we get 6 squared is 36, plus -8 squared is 64. Well, 36 and 64 is really just 100, and the square root of 100 is 10. So the distance between these 2 points would be 10 units, whatever the units are. Okay? So it's that simple. Again, we just sort of give you the formula and we're like, figure it out. Just know that what I showed you on that piece of graph paper is kind of the rhyme and reason behind this formula. Okay, D is the hypotenuse. All right, let's try this again. So for part B, we have -2, -5. Let's call that x1, y1. We also have 4, 7. Let's call that x2, y2. So distance equals, we want to take the difference in our y's. So 4 minus -2 squared plus 7 minus -5 squared. Remember, when you subtract a negative, it really just becomes addition. So 4 minus -2 is really 4 plus 2, which is 6. And then 7 minus -5 is really 7 plus 5, which is 12. So let's see here. 6 squared is 36. 12 squared is 144. So that's going to be like what, 180? So that's going to be the square root of 180. And here it really does depend on the problem. Sometimes they're going to want you to give an exact answer, which means you need to simplify the radical. In other cases, they're going to want you to round your answer to a particular place value. That way you can just go to the calculator, type it in, and round. This case, let's give an exact answer. So we have 180. 180 is the same as 18 times 10. So 180 is 18 times 10. 18 is 9 times 2. 10 is 2 times 5. 9 is 3 times 3. Bring down the 2's. Bring down the 5. We're looking for groupings of 2 identical factors because we have a square root. We can bring out a 3. We can bring out a 2. We're left with a 5 under the radical. So this is equal to 3 times 2 square root 5, or 6 square root 5. And that's your final answer. Okay, so that in whole is the square root property, and a big application of that is the Pythagorean theorem, and a big application of the Pythagorean theorem is the distance formula. Okay.